In the following video, I want to elaborate on how the evacuation application provided in the lectures can be deployed on GCP, short for Google Cloud Platform. The initially provided use case description describes a use case where the on-premise deployment required a significant resource investment, and GCP is suggested as a viable alternative to enable non-functional requirements like availability and scalability. More specifically, in this video, we want to focus on availability, scalability, and deployability. The initial deployment strategy was based on Anthos to provide cloud-agnostic deployment, including on-premise deployment. However, as it does not have a large impact regarding the evaluation options in this case study, normal deployment was used to reduce initial complexity. This diagram shows the ideal deployment, where a few elements, specifically Anthos, Cloud Armor, Cloud DNS, and Cloud CDN, were not introduced to the evaluated deployment, but should be introduced in a production environment to improve, for instance, security. There are two aspects shown in the diagram: the deployment process and the actual deployment. The deployment process is initialized once the developer pushes code to the GitHub repository. The repository contains both the Node.js code for the front-end and back-end, as well as the Docker files to build the Docker images and the Terraform files to build the environment. Furthermore, a cloud build file is included, which is triggered once the developer pushes code to a specific branch. There are several stages for the cloud build. Initially, Docker images are created based on the Docker files in the repository. These images are pushed to the container registry and are thus available for future deployments. Afterwards, Terraform is utilized to initialize an environment based on which branch new code was pushed to. For instance, if there was a push to the development branch, the development environment is initialized. These environments are described in various Terraform files, describing what elements are started and how they should interact. Additionally, MongoDB is deployed externally. Now we will look at the actual deployment process. In this case, we push the code to the production environment and thus build the production Docker images and initialize the production environment. The process is initialized with a push to the production branch, which triggers Google Cloud Build. This can take a while, as it builds and pushes the images, initializes the Terraform build, plans the Terraform build, and finally applies the required changes depending on what elements are currently running and what should be running, and as a consequence either starting or stopping elements. Here, for instance, we can see the images that have just been created for the production environment, both the backend and the frontend. After the build process is done, the environment's up and running. In this case, there were no changes to the Terraform files and thus no changes to the actual deployment. As we can see, both deployments are up and running, both development and the production environment. Furthermore, the underlying infrastructure is set up as well, for instance the networks and serverless VPC access nodes. Meanwhile, both memory store is running on the Google Cloud Platform and a MongoDB instance is running on Mongo Atlas. To be able to compare the current deployment to other alternatives, several other deployment strategies have been used, including Google Kubernetes Engine with Autopilot, Google Compute Engines, and a local deployment. The local deployment is based on a Docker Compose file, using the same Docker files as the cloud deployments, including a Redis Docker image. This enables seamless transitions to other deployment strategies. For instance, Google Kubernetes Engine, where Docker images based on the same Docker file can be used. The Google Kubernetes Engine deployment is based on a simple cluster with 3 nodes and both the frontend and backend image running in the cluster. Additionally, an HTTPS load balancing service is started to enable load-balanced external access. The Google Compute Engine's deployment is based on 2 virtual machines, one for the backend and one for the frontend, connected with a VPC. To evaluate the performance, JMeter was used to emulate a large amount of users accessing the services. Here, 1,000 users were used with a ramp-up period of 10 seconds and a run of 5 minutes for each deployment strategy. The results indicate that there's little variance between the cloud deployment strategies, and all are able to satisfy the initial performance requirements in terms of being under 1 second. An interesting aspect to note is that even though GKE, Cloud Run, and GCE use instances with different specs, they perform somewhat the same. This indicates that the choice in the end depends on the configuration options and other parameters such as autoscaling and load balancing options when choosing one over the other.